Visit Chandra's beautiful universe. Cassiopeia A. A new study from NASA's Chandra X-ray Observatory has revealed that the insides of a star turned on itself before it spectacularly exploded. This happened in the star that created the Cassiopeia A, or Cas A, supernova remnant, which is one of the best-known, well-studied objects in the sky. Over 300 years ago, however, it was a giant star on the brink of self-destruction. The new Chandra result reveals that just hours before it exploded, the star's interior violently rearranged itself. This last-minute shuffling of its stellar belly has profound implications for understanding how massive stars explode and how their remains behave afterward. As massive stars age, increasingly heavy elements form in their interiors by nuclear reactions, creating onion-like layers of different elements. Their outer layer is mostly made of hydrogen, followed by layers of helium, carbon, and progressively heavier elements, extending all the way down to the center of the star. Once iron starts forming in the core of the star, the game changes. As soon as the iron core grows beyond a certain mass, about 1.4 times the mass of the Sun, it can no longer support its own weight and collapses. The outer part of the star falls onto the collapsing core and rebounds as a core collapse supernova. The new research with Chandra data reveals a change that happened deep within the star at the very last moments of its life. After living for more than 1 million years, Cas A underwent major changes in its final hours before exploding. Just before the star in Cas A collapsed, part of an inner layer with large amounts of silicon traveled outward and broke into a neighboring layer with lots of neon. During this violent event, the barrier between these two layers of the onion, so to speak, would have disappeared. There are several significant implications for this inner turmoil inside of the doomed star. First, it may directly explain the lopsided rather than symmetrical appearance of the Cas A remnant. Second, a lopsided explosion and debris field may have given a powerful kick to the remaining core of the star, now a neutron star, explaining the high observed speed of this object. Finally, the strong turbulent flows created by the star's internal changes may have promoted the development of the supernova blast wave, facilitating the star's explosion. After more than a quarter century of observations of Cas A, this is just the latest example of how Chandra continues to find new discoveries about this iconic exploded star and its impact on astrophysics.